All right, section 1.1. You guys, if you look up on the board, your next quiz is on the 13th of September. It's over 3 sections, 1-1, 1-2, 1-3. Your test will be on the 20th over the first 4 sections. Guys, you will not be using calculators. We're going to have negative numbers here. We're going to be breaking down radicals, all that stuff. You're going to have to be able to do that on your paper. So pay attention. We're going to work through it today and again on Tuesday for extra practice. But just to kind of reintroduce, make sure everybody knows the workings of the coordinate plane. Here's our coordinate plane, our x-axis and our y. Our x is our horizontal axis, the one that goes left and right, the horizontal. Make sure we know our vocabulary words. The y-axis is our vertical axis, the one that goes up and down. Right here in the middle, what's this middle point called? The origin, good. What is the ordered pair at the origin? 0, 0, good. All right, now, if you guys are given an x and a y, notice this is a point. You know it's a point because there's a comma separating the two values, and there are parentheses. When you are plotting a point, some of us get a little confused, especially when we're trying to do plotting lines and stuff like that. But your x value tells you first to go left and right, and your y value then tells you to go up or down. All right, we're going to talk about different placement and the different quadrants and that sort of thing, so we need to know the quadrants. If I say something's in quadrant 3, you need to know where that is and what the signs are. So quadrant 1 is top right, and both your x and your y are positive, positive. Plus, plus. Quadrant 2, you go in counterclockwise direction. It makes like a C. I don't know if you guys have seen that before. But in quadrant 2, your x value is negative and your y value is positive. In quadrant 3, both your x and your y are negative. And in quadrant 4, your x is positive and your y is negative. So if I tell you that a point lies in quadrant 4, you should know, okay, oh, my x value is positive, my y value is negative. Everybody with me on that? All right, we're going to talk today about distance and midpoint. All right, distance between 2 points, the distance from here to there. You guys have heard before the distance from A to B, or how far is it to Disney World, something like that. But the distance between 2 points, you guys first learn to find distance on a coordinate plane by counting. If you have a straight horizontal line, you can count how far it is from one point to the other, right? Just go count. If you had a vertical line, you could count how far it is from one point to another. But if you don't have something that is completely vertical or completely horizontal, you can't count from here to here and get an accurate count. So that's why we have the distance formula. Now, if I asked you the distance between these 2 points, all right, just say this was 1 and this was 5. What is the distance between those 2 points? How many spaces? If this x value is 1 and this is 5, how far is it from one point to another? 4. Do you guys agree with me that the distance from 1 to 5 is 4 spaces, and the distance from 5 to 1 is 4 spaces? Okay? Distance is always measured positively. You don't ever say, I drove negative 5 miles or something like that, right? So that's where this absolute value comes from. When you talk about distance, you are finding the value from one point to another. It doesn't matter whether you go from point A to B or B to A. The distance itself stays positive. That's why those are in absolute values. But how did you find the answer 4? How'd you come up with 4? Very basic. This isn't a trick question. You subtracted, right? You subtracted 5 minus 1 and got 4. If I said that this y was 2 and this y was 8, how far is it from here to here? You guys would tell me it's what? 6. How'd you get that? Subtracted. All right, so think about that. I just want you to think about that because you guys are going to be using the distance formula. Some of you know the distance formula. Some of you are not familiar with the distance formula. You will not be given the distance formula on the test or quiz. You need to know it. So the way that we have derived the distance formula is kind of what I just talked about, of counting how far it is from one x to the other and how far it is from one y to the other. But if it's not a straight horizontal or vertical line, you have to use this formula here. So I want you guys to write that down, or it's already written down for you, duh. But I'm going to talk about it for a second. All right, we get caught up, like with the slope formula, y2 minus y1. You guys are like, I don't know which one y2 is which one. In the distance formula, it does not matter the order, right? Does not matter the order that you subtract. Does anyone know why it doesn't matter? Let's think about this. If I had one of my x values was 5 and the other one was -3, or let's just say 3. Why?
Because it's squared.
Because it's squared. Good, very good. If one of my x values was 5 and one was 3, and we wrote it 5 minus 3 versus 3 minus 5. What is each parenthesis? What's being done to each parenthesis when you subtract your x's and your y's? They're being squared. So think about this, guys. If I say 5 minus 3, I get 2. And when I square it, I get what number? 4. If I say 3 minus 5, I get -2. When I square -2, what number do I get? 4. So don't get hung up that, oh, I don't know which one x2 is and which one. That doesn't matter. What matters is you keep x's together and you keep the y's together. So everybody see that? When you square a number, it's always positive. So should you ever get a negative underneath this radical? No, you can't measure distance in a negative value. So little things like that should kind of be in the back of your mind when you're doing these problems, so you're not going through and being like, how'd I get a -10 or something like that? You shouldn't. So go back and check your signs. So let's do a couple problems. This is applying the distance formula. Okay, which points, P or Q, is closer to A? So let's just draw a little picture. All right, here's my A. Then I have point P, and I have Q. They want to know which one's closer. So in a sense, guys, what do I have to do to figure out which point is closer? I need to use the distance formula. How many times? Twice. I need to know how far it is from P to A, and I need to know how far it is from Q to A, and then I can compare which one is closer. So the way that I suggest, lots of times it's really easy when you have 2 points that are next to each other to mix up your x's and your y's. I always rewrite my points on top of each other. So I'm going to find the distance between P and A. So P is 1, -2, and A is 5, 3. Then I'm going to find the distance between Q and A, and I'm going to compare them, see which one's closer, which one's further away. So 8, 9, and then 5, 3. Everybody with me? What I want to see from you is this kind of work. Do not skip steps, or else I will not give you full credit. There are so many areas, so many ways that you can make tiny little mistakes with your signs and stuff. So just take the time to be organized. I personally always set up my distance formula before. I don't put anything in. I just get it set up. I know that there is a plus sign joining my 2 parentheses and a minus sign inside. Now I don't have to think about minus and negative and all that stuff. I can just stick my numbers in. Does everybody see that? I have my x values and my y values. It's very simple to see x's are what are my 2 x's? 5 and 1. 1 and 5. Does it matter if you say 1 minus 5 or 5 minus 1? No, because when you square it, it's going to become positive. So I'm just going to say 1 and 5 here. My y's are -2 and 3. Questions? All right, now we're going to simplify. What's 1 minus 5? So I have -4 squared plus what's -2 minus 3? -5. Okay, so now I simplify more. We're getting a little smaller. What's -4 squared? 16. What's -5 squared? 25. And then I add 16 and 25. If you don't know that off the top of your head, write 16 and 25. 1 carry the 1. Square root of 41. Now we're going to talk about breaking radicals down in a second. All right, so the distance from point P to A is square root of 41. I don't know what that is, but that's what the value is. So, yes?
The -2 minus the +3, if you would have put the -2 on the other side.
It would have been 3 minus the -2, which would have been 3 plus 2.
It would have been.
Yep. So I'm going to come over here and do the exact same thing. Let's get our distance formula set up. I have my parentheses that are joined by a plus sign, and the minus sign goes in the middle. So here's my x, here's my y. My two x's are 8 and 5. 8 minus 5 or 5 minus 8 does not matter. You can put it either order you want, because negative 3 and positive 3 squared is the same thing. 9 minus 3, 3 minus 9, again, doesn't matter. So when we simplify, 8 minus 5 is 3 squared, plus 9 minus 3 is 6 squared. What is 3 squared? 9, good. What's 6 squared? 36. And when I add 36 and 9, I get 45, okay? Now, which point is closer? Do you guys know the square root of 41, or do you know the square root of 45? No, but which number is smaller? 41, right? So the square root of 41 is smaller than the square root of 45. So you would say that point P is closer to point A. But you'd have to do all that work to show me that. Now, if you guys left your answers in this kind of radical form, you would not get full credit. It's always going to say, leave your answer in simplified radical form or give an exact answer. You will not have calculators. An exact answer is not 9.736577777. That's not exact. Exact means you break down the radical. Now, some of us know how to do this and some of us don't. So we're going to have another little lesson here, and then we're going to practice this again next week. But if I have 45, all right, I like to do upside down division. You start with your smallest prime number. You start with 2. 2 doesn't work. Try 3. Yes, ma'am. After 3, then I try 5. Then I try 7. 2 does not go into 45 because it's not an even number. But let's try 3. Does 3 go into 45? Yes? Okay, 3 goes into 4 once with 1 left over. 3 goes into 15 how many times? Sorry, yeah, 3 goes into 15 how many times? 5. You guys, bye, honey. You guys with me? Okay, so let's go again. Does 3 go into 15? How many times? 5, all right. So now you've broken this problem down. You've broken this number down into its prime factors. The way that you break down a radical when using prime factorization, anything that is a pair, you can pull out. So I can pull out one pair of 3s. So I have a 3 on the outside. And then do I have a pair of 5s? So then that stays underneath the radical. All right, we're going to work on this a little more because this can be a little difficult. Say you had 52, square root of 52. And you're like, that might break down, I think. I don't know. So we're going to do our upside down division. Does 2 go into 52? Yeah. 2 goes into 5 twice with 1 left over. So 2 goes into 12 6 times. Does 2 go into 26?
Yeah.
How many times? 13. Can I break 13 down anymore? No. So what would my radical look like when I simplify this? How many pairs of 2 can I pull out? 1 pair, so that goes on the outside, and then 13 stays on the inside. All right, what if I had 72? I'm going to break down 72, square root of 72. All right, so I do know 8 and 9, guys, but 9 has the perfect square in it, but so does 8. That's why you should not just go with 2 factors you know. Use the prime factorization. 2 goes into 72. 2 goes into 7 3 times with 1 left over, so 36. Break it down again. 2 goes into 36. 2 goes into 3 once with 1 left over, 18. 2 goes into 18 how many times? 9. Does 2 go into 9? No. What does? 3. 3 goes into 9 3 times. Do you see lots of pairs of stuff? Okay, I see 1 pair of 2s. I'm going to bring outside. I also see what? A pair of 3s. So you just multiply it together. And then what's left over? So that stays inside. So it's 6 square root of 2. Because you're not going to get a lot of tiny numbers. You're going to get a number like 528. And you have to break that down. So you're going to have to use the prime factorization. Questions? We'll practice this more, I promise. All right, let's do some examples here. Find the distance between the following points. Leave your answer in radical form. That means no decimals and break it down. So here's my x's, here's my y's. Let's get our distance formula set up. I have my two parentheses that are joined by a plus sign and they're squared. And my minus sign goes in the middle. So my x's, -6 and 1. Doesn't matter where you put them. Just put them together. So I have -6 and 1. And then my y's are -1 and 5. If you switch the order, that's fine. Just make sure you pay attention to signs. So -6 minus 1 is -7 squared plus -1 minus 5 is -6 squared, correct? What's -7 squared? 49, good. What is -6 squared? 36. Okay, if you don't know that in your head, write it down to the side. 9 and 6 is 15. Carry the 1, I get 85. So I have the square root of 85. And we're not sure if that breaks down or not. So let's do our upside down division and just check. Does 2 go into 85? No. Does 3? What's 8 plus 5? 13, so that's not going to work. What about 4?
No.
5? Yep, 5 goes into 8 one time with 3 left over. 5 goes into 35, 17. Anything going to go into 17?
No.
Nope, so then you're good. Square root of 85. Just leave it just like that. If it doesn't break down, then don't worry about it. Yes, sir. Not right now. Wait till she comes back. All right, next one. Again, get your x's and y's set up. I would write them on top of each other and then get your formula set up. You have two parentheses that are squared, joined by a plus sign, and the minus sign goes in the middle here. So 0 minus 10 or 10 minus 0, either way. 4 minus 3 or 3 minus 4, either way is fine. 0 minus 10 is going to give me -10 squared, plus 3 minus 4 is -1 squared. What is -10 squared? 100. Good. What is 1 squared? 1. So I get the square root of 101. Doesn't look like it breaks down, but let's just check. Okay, 101. 2 will not go into 101. 3 will not. 5. 7. Is anything going to go into it? Nope. So you're good. Just leave it just like that. Sometimes it'll break down, sometimes it won't, but you need to always check to see if it does break down. All right, again, same thing. We're going to get our distance formula ready. Don't even worry about putting numbers in. Just go ahead and write it. The more you guys write it, the easier this becomes. You have a plus sign that joins the two parentheses together that are squared and a minus sign in the middle of the parentheses. So I have my x and my y. I'm just going to put -2 first and then 5, -3, and 7. You can switch the order. That's fine. Just keep x's together and y's together. What's -2 minus 5? -7, okay. And then what's -3 minus 7? -10, good. So -7 squared gives me 49. -10 squared gives me 100. So I have the square root of 149. That looks like something goes into it. Let's try. 149. 2? No. 3? Does 3 go into 149? 9 plus 1 is 10 plus 4 is 14? No. 5? What about 7? 7 looks like it'll go in. 7 goes into 14 twice. Does 7 go into... No. Is anything going to go into this one? No. So then you're done. Just say you came out with a square root of 150. Let's break down 150. Just say this was the answer. 2 goes into 150, correct?
Yeah.
2 goes into 15. 7 times with 1 left over. 5. Does 2 go into 75? No. Does 3?
No.
Yeah, 3 does. 3 goes into 7. How many times? 2 times. Yeah? With 1 left over. 3 goes into 15 5 times. Okay. Does 3 go into 25? No. Does 5?
Yeah.
Yes. So if this were my answer, square root of 150, what would my radical broken down look like? I can take out a pair of 5, so it'd be 5 square root 6. Very good. Good that you multiplied those 2 left over inside. Good. Very good. All All right, next thing we're going to talk about, we're almost done, is the midpoint of a line segment. A line segment is just 2 points joined together. Where is the midpoint? In the middle. Very good. We're going to be finding the midpoint. Guys, the midpoint formula is super duper easy. You add the x's, divide by 2. You add the y's, divide by 2. I just gave a quiz in pre-calc, and I had so many people that put a minus sign in between these two, and they got every answer wrong because that's not what it is. You add the 2 x's, divide by 2. You add the 2 y's, divide by 2. Notice your answer is written with parentheses on the outside and a comma separating the 2 numbers. So let's do these last 2 examples. We're going to find the distance and the midpoint for both of these, and then we'll be done. I want to find the distance and the midpoint. So x and y. X and y. This will be a question on your quiz. Find the distance and the midpoint of the following points. So get your distance formula set up. I have my 2 parentheses that are joined by a plus sign and they're squared, and then a minus sign in the middle. Does it matter if I put 9 minus 17 or 17 minus 9? No. The big thing that is important is that x's stay with x's and y's stay with y's. So 17 minus 9. And then I'm going to say 3 minus 4. You could do it the other way if you wanted to. But what is 17 minus 9?
8.
So I have 8 squared plus, what's 3 minus 4? Negative 1 squared. Okay. What's 8 squared? 64 plus 1. So I have the square root of 65. Does that break down?
Yep.
Okay, let's try. Does 2 go into 65? No. 3? No. 5? Okay. 5 goes into 6 1 time with 1 left over. So 5 goes into 15 13 times. Does that break down? No. So there you go. You're good. Now if we're going to find the midpoint, guys, the midpoint, you take the 2 x's and do what with them? Add them and divide by 2. You take the 2 y's and add them, divide by 2. It's different in the midpoint formula than it is in the distance formula, so just pay attention to that. So 17 plus 9 is how much? 26. And then 26 divided by 2 is 13. Perfect. So 4 plus 3 is 7. Does 7 divide by 2 pretty? No. Can I simplify 7 over 2 anymore? No. You can just leave it as an improper fraction. If it was 8 over 12 or something, 12 over 8, simplify that. But you don't have to change it to a mixed number or to a decimal. If you want to, that's fine, but you don't have to. So there's the midpoint. Let's do another one. Let's get our distance formula set up. We're going to write our 2 parentheses that are joined by a plus sign and then a minus sign in the middle. So I'm going to say 5 and negative 4 and then 6 and negative 1. When I have 2 negatives, guys, a minus and negative becomes what? Positive. Minus and negative becomes positive. So this is 9 squared plus 7 squared. What is 9 squared? 81. What's 7 squared? 49. Now I need to add those 2 together. Write 81 and 49 to the side. 0, 130. So the square root of 130. Does that break down? Let's try. Maybe it does, maybe it doesn't. Does 2 go into 130? Yep, 2 goes into 13 6 times with 1 left over, right? 2 goes into 10 5. Does 2 go into 65?
No.
3? No. 5? Yep, 5 goes into 6 once with 1 left over. 5 goes into 15 13 times. Do I have any pairs?
No.
Any factors that are pairs? No, so that's it. This absolutely does not break down, and that's okay. Sometimes it will. Girls, I'm almost done. Sometimes it will, sometimes it won't. But to find the midpoint, what do we do with our x's and what do we do with our y's? Add them. Negative 4 plus 5 divided by 2, comma, 6 plus negative 1 divided by 2. Yes, I understand that's the same as 6 minus 1, but I would get in the habit of writing that plus sign so you guys don't forget. But what is negative 4 plus 5? 1. 1 does not divide pretty by 2, so just 1/2. That's fine. What is 6 plus a negative 1? 5. 5 does not divide by negative 2 pretty, so there is your midpoint. 5/2. We have got to get confident with breaking down radicals and stuff, though, because you guys are going to have them. So you might have a radical as big as like 512. I just made that up. Square root of 512. Does that break down? You're like, I don't know. So come up just nice and easy. What's the smallest prime number that's going to go into 512? 2. Good. 2 goes into 5 twice with 1 left over. How many times does 2 go into 11? 5 with how many left over? 1. And 2 goes into 12 how many times? 6. Okay, good. So, again, what number goes into 256? 2. 2 goes into 2 once. 2 goes into 5 twice with 1 left over, right? 2 goes into 16 how many times? 8. Okay, good. Does 2 go in here again? Sure. Okay, 2 goes into 12, 6. 2 goes into 8. Okay. Does 2 go in there again? Okay. 2 goes into 6, 3. 2 goes into 4, 2. Good. Again? Okay. 2 goes into 3 once with 1 left over. 2 goes into 12. 6 times. Again? Oh my gosh. Okay. 2 goes into 16 how many times? 8. Again? 2 goes into 2. 2 goes into 8 how many times? Oh my goodness. We got a whole bunch of what? Whole bunch of 2s. Now, great. You guys just divided 512 17 times by 2. Wonderful. But how do you show me that this is the prime factorization and it comes into something? Take out pairs. So I have one pair of 2s. I'm going to write it down. I have another pair of 2s. So I multiply it. I have another pair of 2s. Multiply it. And then another pair of 2s. So I multiply it. And then what happens with that lonely little 2 at the end? It has to stay inside the house. So when we actually condense this, multiply it together, what is 2 times 2? Times 2 is 8. Times 2 is 16. So this is 16 square root of 2. You are expected, guys, to break down radicals. So 512 breaks down into 16 root 2. You will not have calculators, so make sure you guys can do your prime factorizations. All right, Tuesday in class, we will practice and practice and practice together, and then we'll move on to 1.2.